A car is traveling on a straight road for t values greater than or equal to 0 and less than or equal to 24. The car's velocity in meters per second is modeled by the piecewise linear function defined by the graph. In Part A, we were asked to find the integral from 0 to 24 of v of t dt. So the integral is shown here, and all this integral is the area underneath this graph. So we solve it as if we're finding the area of a trapezoid. And I showed the formula here and got my answer to be 360 meters. What that means is the car travels 360 meters in the 24 seconds. For Part B, we were asked to find v prime of 4 and v prime of 20. So v prime of 4 actually does not exist because v of 4 is not differentiable. It's not differentiable because the derivative approaching from the left and right are not equal. The slope approaching from the left equals 5, and the slope approaching from the right equals 0. So the derivatives don't match, therefore v prime of 4 does not exist. V prime of 20 does exist, however, because the derivative approaching from both sides is equal. So we can solve as shown and get our answer to be negative 5/2 meters per second squared. For Part C, we were asked to find the car's acceleration in meters per second and write a piecewise function for a of t. So to do that, first I found the values 5, 0, and negative 5/2, which are the slopes of the three pieces of the function. And each slope is only consistent over a certain time interval. 5 is from t values of 0 to 4. 0 is t values from 4 to 16. And negative 5/2 is t values from 16 to 24. A of t does not exist at t equals 4 and t equals 16 because neither are differentiable since the slopes approaching from the left and right are not equal. For Part D, we were asked to find the average rate of change of v over the interval 8 to 20. And we also were asked, does the mean value theorem guarantee a value of c for c between values 8 and 20? Such that v prime of c is equal to this average rate of change. Well, first, starting off with the average rate of change, we took v prime of 20 minus v prime of 8 over 20 minus 8 and found that to equal negative 5.6 meters per second squared. However, the mean value theorem does not apply to v on the interval from 8 to 20 because v is not differentiable at t equals 16 because, as stated before, the derivatives approaching from the left and the right are not equal.